3I Atlas just accelerated during perihelion passage, and that changes everything. Objects don't accelerate when passing close to the sun unless forces are acting on them that we don't understand, or unless those forces are artificial. What we observed during the closest approach violates our models of natural cometary behavior, and the implications of this acceleration could rewrite our understanding of what this object actually is. Let me be precise about what happened. On October 29th at perihelion, 3I Atlas reached its closest point to the Sun at 0.7 astronomical units. Standard orbital mechanics predicted a specific velocity at that point based on solar gravity and the object's trajectory. We measured the actual velocity. It was higher, significantly higher. The object accelerated by approximately 300 meters per second more than gravitational models predicted. 300 meters per second doesn't sound like much. It's roughly the speed of sound. But in orbital mechanics, that's enormous. That's enough delta V to change an interstellar trajectory. That's enough to alter course intentionally. That's enough to slow down instead of speeding away. And that acceleration happened during the brief window when the object was closest to our Sun, closest to maximum solar observation opportunity, and closest to potential communication range with Earth. The timing is suspicious. Natural outgassing from comets does produce thrust. As ice sublimates into gas and escapes the surface, it pushes the comet in the opposite direction. We've observed this with many comets. But outgassing thrust is predictable. It follows patterns based on solar heating, rotation rate, and surface composition. 3I Atlas didn't follow those patterns. The acceleration was directional, sustained, and perfectly timed. Here's what makes it impossible to dismiss as natural. The acceleration vector wasn't random. It wasn't perpendicular to the Sun, as you'd expect from simple outgassing on the illuminated side. The thrust was applied in the direction of travel along the velocity vector, exactly as you would if you wanted to increase speed in a specific direction. That's trajectory optimization. That's powered flight. That's propulsion. NASA's official explanation is asymmetric outgassing. They claim irregular surface features created venting that happened to align with the direction of travel. They point to previous comets that showed small non-gravitational accelerations. They say this is unusual, but not impossible, within the bounds of natural phenomena. But their own models show the outgassing required to produce this acceleration would need to be visible. Massive plumes, significant coma expansion, detectable gas production rates. We saw none of that. The Hubble Space Telescope observed 3I Atlas throughout perihelion passage. High-resolution imaging, spectroscopic analysis, continuous monitoring. The coma didn't expand significantly. Gas production rates were moderate, consistent with solar heating, but nowhere near sufficient to explain the observed acceleration. The object remained relatively quiet visually while somehow generating enormous thrust. Let me give you the math. To accelerate a 400-meter object by 300 meters per second through outgassing, you need to eject mass. Lots of mass. At typical cometary outgassing velocities of around 500 meters per second, you'd need to eject roughly 60% of the object's mass. That's impossible. The object would visibly shrink. The coma would be enormous. We detect the gas spectroscopically at levels far beyond what we observed, unless the exhaust velocity is much higher. If you're using something other than sublimating ice, if you're using actual propulsion, you can achieve the same thrust with much less mass. Ion drives, for example, have exhaust velocities 10 times higher than outgassing. Chemical rockets even higher. Nuclear propulsion higher still. With advanced propulsion, you could produce the observed acceleration while ejecting only a small percentage of mass, potentially below our detection threshold. The acceleration wasn't instantaneous either. It built up gradually over approximately 18 hours, peaked near perihelion, then declined over the next 12 hours. That's a 30-hour powered flight window. Natural outgassing responds to solar heating, which changes gradually, so a gradual acceleration profile makes sense for comets. But the timing precision is troubling. Maximum thrust occurred within 2 hours of perihelion, the optimal time for velocity changes to affect trajectory most efficiently. This is basic orbital mechanics. The Oberth effect says thrust applied at the lowest point of an orbit, closest to the gravitating body, produces maximum change in orbital energy. It's like pushing a swing at the bottom of its arc. If you wanted to alter an interstellar trajectory efficiently, you'd apply thrust at perihelion. That's exactly what 3I Atlas did. Now let me address the skeptics who say, I'm jumping to conclusions. Fair point. Let's examine alternative explanations. Theory 1. Subsurface pressure release. Maybe volatiles trapped beneath the surface reached critical pressure during solar heating and vented explosively through cracks aligned with the velocity vector. Problem: we'd detect the venting. Infrared observations would show hot spots. We'd see the gas spectroscopically. None of that appeared at levels consistent with the required thrust. Theory 2. Rotation-induced jetting. Maybe the object's rotation aligned vents with the velocity vector during perihelion. Problem: we know the rotation period, 11.7 hours. Any rotation-aligned jet would pulse with that period, creating oscillating acceleration. We'd measure thrust on, thrust off, thrust on, as the vent rotates into and out of sunlight. The observed acceleration was smooth and sustained for 30 hours, much longer than multiple rotation periods. Theory 3. Shape effects. Maybe the object's irregular shape created unusual pressure distributions that focused outgassing directionally. Problem: shape effects would require extreme asymmetry. Computer models of irregular bodies show you need geometric configurations that look engineered, not natural, to produce directed thrust. And even then, you can't maintain directional thrust through multiple rotations without it averaging out. Theory 4. Measurement error. Maybe we miscalculated the expected velocity and the object actually followed gravitational predictions. Problem: we have extremely precise measurements. Multiple observatories independently confirm the trajectory. Orbital mechanics is one of our most reliable predictive sciences. The probability of all measurements being wrong in the same direction is effectively zero, so we're left with uncomfortable options. Either 3I Atlas experienced an extraordinary natural process we've never observed before and don't understand, or the acceleration was artificial. Both possibilities are scientifically significant. If it's natural, we're missing fundamental understanding of volatile mechanics or cometary structure. If it's artificial, we're observing technology from another civilization. The acceleration also changed the trajectory. Not dramatically, but measurably. Before perihelion, projections showed 3I Atlas would exit our solar system on a specific path. Post-perihelion calculations show a slightly different path. The change is consistent with the observed acceleration. If this was course correction, it worked. The object is now on a trajectory that will pass closer to Mars than originally predicted. Mars' closest approach happens in 93 days. Original calculations showed a distance of 280,000 kilometers. Updated projections show 160,000 kilometers. That's close. That's within the orbital radius of Deimos, Mars's outer moon. That's surveillance range if you're interested in observing our planetary exploration activities. China knows this. Their rapid launch mission I mentioned previously, they're not targeting 3I Atlas anymore. They redirected to a Mars intercept trajectory. They plan to observe the object during its Mars flyby with proximity instruments. That's strategic brilliance. They'll get close-range data without the fuel cost of matching velocity with the object. They let the object come to them at Mars. The United States is scrambling to respond. There's serious discussion about diverting one of the Mars orbiters to observe 3I Atlas during the flyby. The problem is, Mars orbiters are in stable orbits optimized for surface observation, not for chasing fast-moving interstellar objects. Moving an orbiter uses fuel that shortens mission life. It's a trade-off between studying 3I Atlas and continuing Mars science. Europe's Mars Express orbiter has the best positioning for potential observation. They're running simulations to see if they can adjust orbit enough to get high-resolution images during the flyby without compromising the mission. The decision needs to happen within weeks because orbital mechanics requires lead time. Every day of delay makes the required fuel burn larger. Here's what bothers me most about the acceleration. If 3I Atlas can maneuver, if it has propulsion capability, then everything we've assumed about its mission profile might be wrong. We thought it was passing through. A fast flyby gathering data, then continuing into deep space. But objects with propulsion can brake. They can enter orbit. They can stay. The acceleration we observed was in the prograde direction, adding velocity. That seems counterintuitive. If the goal is to stay in our solar system, you'd want to decelerate. But orbital mechanics is subtle. By accelerating at perihelion, you raise your orbit at the far end. You change your trajectory in ways that might enable future maneuvers. Maybe this was step one of a multi-burn sequence. Consider this scenario. 3I Atlas accelerates at perihelion, raising its trajectory slightly. It continues outward toward Mars. During the Mars flyby, it performs another burn. This time decelerating, using Mars gravity assist combined with propulsion. The combined effect drops its velocity enough to become gravitationally bound to the Sun. It enters a long elliptical orbit instead of escaping the solar system. That's how you do it with minimal fuel. You don't fight gravity directly. You use it. Multiple passes with small burns at optimal times add up to major trajectory changes. If 3I Atlas has propulsion and navigation capability, this acceleration could be the first visible sign of orbital insertion maneuvers. The alternative is even more interesting. Maybe the acceleration wasn't about trajectory change at all. Maybe it was a demonstration, a signal. Look at us, it says. We're not a rock. We're not natural. We have propulsion. We can maneuver. Notice us. Understand what we are. That interpretation suggests the acceleration was meant to be obvious, meant to generate exactly the debate we're having now. From an engineering perspective, demonstrating propulsion capability makes sense before attempting communication. If you're approaching an unknown civilization, you want them to understand you're artificial before you start broadcasting signals. Otherwise, they might dismiss your transmissions as natural radio sources. But if they see you maneuver in impossible ways, they know your technology. Then when you transmit, they're listening. We haven't detected clear transmissions from 3I Atlas yet, but we're looking now with different assumptions. Before the acceleration, we were monitoring for natural electromagnetic emissions. Now, we're specifically searching for structured signals, for patterns, for communication attempts. The Allen Telescope Array is dedicating time to 3I Atlas. The Very Large Array is coordinating observations. We're listening across wider frequency ranges with more sophisticated signal processing. If there's a signal, we'll find it. The question is whether we'll recognize it. Communication from another civilization might not look like our radio. It might be encoded in ways we don't expect. It might use modulation schemes we haven't invented. It might require detection methods we don't have. We're looking for needles in haystacks while not being entirely sure what needles look like. The acceleration also changes the risk assessment. Before, 3i Atlas was a passive object. Interesting scientifically, possibly artificial, but not actively doing anything. Now, we know it can maneuver. That means it has agency, it can make decisions, it can change course, it can potentially target specific locations. That transforms this from a scientific curiosity into a potential security concern. I want to be very clear. I'm not suggesting 3i Atlas is hostile. I'm saying we need to consider possibilities we weren't considering before. An object with propulsion has capabilities beyond passive observation. It could adjust trajectory to impact the planet. It could enter orbit around Earth. It could deploy smaller craft. These scenarios are speculative, but they're now physically possible in ways they weren't before we observed propulsion. The Department of Defense is involved now, not publicly, but there are classified briefings happening. Military space surveillance assets are tracking 3i Atlas continuously. There are contingency plans being developed for various scenarios. This isn't paranoia. It's prudent risk management when dealing with unknown technology that can maneuver. The scientific community is divided. Some researchers are excited. This could be first contact, they say, the most important discovery in human history. Others are cautious, arguing we're seeing ambiguous data and shouldn't jump to conclusions. Still others are concerned about the security implications of announcing that an object with propulsion of unknown origin and intent is approaching Earth. The public isn't being told most of this. Press releases talk about interesting trajectory anomalies requiring further study. They mention natural outgassing as the likely explanation. They don't discuss propulsion. They don't mention the impossibility of generating the observed thrust through natural means. They don't address the precision timing of the acceleration. The information is being carefully managed. I understand the argument for caution. Announcing that an artificial object with propulsion is approaching Earth could cause panic. Markets could crash. People might do irrational things. But I also believe people have a right to know. This affects everyone. If we're approaching first contact, humanity should be informed and involved. Keeping this secret from the public while governments prepare classified responses is paternalistic and potentially dangerous. Here's what should happen. International coordination. Every space-capable nation should be sharing data and coordinating observations. We should have agreements about what actions are permissible and what requires consensus. If 3i Atlas changes course toward Earth, for example, we need predetermined protocols for communication attempts, for monitoring, for potential response. We can't be making up policy in real time during a crisis. The United Nations Office for Outer Space Affairs should be convening emergency sessions. The Committee on the Peaceful Uses of Outer Space should be developing frameworks for this exact scenario. Instead, most of the discussion is happening in classified channels in a handful of countries. That's not adequate for something this significant. We also need public scientific discourse. The acceleration data should be published openly. Let the worldwide scientific community analyze it. Let researchers propose theories and test them against the data. Crowdsourcing analysis often finds insights individual groups miss. By keeping this close hold, we're limiting the intellectual resources applied to understanding it. The acceleration happened 3 days ago. We've been analyzing the data continuously. Multiple teams have verified the measurements independently. The acceleration is real. The magnitude is confirmed. The timing is verified. The directional nature is established. These are facts. What they mean is subject to interpretation, but the observations themselves are solid. NASA will eventually publish a paper, probably in a few weeks after internal review. It will present the data objectively and discuss possible explanations, including natural processes. It will be careful and measured and scientifically rigorous. It will not speculate about artificial propulsion because speculation isn't appropriate in peer-reviewed literature without extraordinary supporting evidence. But we can speculate here. We can discuss possibilities that formal publications won't touch. And the possibility I keep returning to is propulsion. Not because I want it to be true, but because it fits the data better than alternatives. The acceleration magnitude, the directional nature, the timing, the lack of visible outgassing, all of these point toward artificial thrust. If I'm right, if 3I Atlas is propelled, then the next 93 days are critical. The object is approaching Mars. If it performs additional maneuvers near Mars, that confirms capability and potentially indicates intent. If it maintains course and continues outward, maybe the perihelion acceleration was one-time course correction and not part of an insertion sequence. We'll know relatively soon. Mars flyby happens in 3 months. We'll have observations from Earth telescopes, potentially from Mars orbiters, possibly from China's proximity mission. We'll measure any trajectory changes. We'll look for additional thrust. We'll monitor for transmissions. We'll analyze surface features for evidence of artificial structures. The data we gather in that brief encounter window could answer questions that have occupied humanity for millennia. Are we alone? That's the fundamental question. 3I Atlas might answer it. Not with a hello message or a dramatic landing, but with propulsion, with maneuvers that defy natural explanation, with technology that reveals intelligence. Sometimes the most profound answers come not from communication, but from observation, from seeing something that couldn't exist naturally, from measuring forces that require intent. The acceleration at perihelion might be the moment future historians point to, the moment when humanity transitioned from wondering if we're alone to knowing we're not. The moment when an object from another star system demonstrated capability that only technology can produce. The moment everything changed. Or maybe I'm wrong. Maybe there's a natural explanation we haven't thought of yet. Maybe exotic ice structures or unusual volatile mechanics or some combination of factors we don't understand produce the observed acceleration naturally. That would still be scientifically revolutionary. That would still require rewriting textbooks about cometary physics and volatile behavior. Either way, natural or artificial, what happened at perihelion is profound. But I don't think I'm wrong. I've spent 40 years studying physics. I understand orbital mechanics. I know what's possible naturally and what requires intervention. And what 3I Atlas did requires intervention. It requires propulsion. It requires control. It requires technology. In 93 days, we'll have more data. In 93 days, the Mars flyby happens. In 93 days, we might see additional maneuvers that confirm what the perihelion acceleration suggested. Or we might see nothing, and the mystery deepens. But either way, 3I Atlas has shown us something extraordinary. It accelerated. It maneuvered. It changed course. And objects that can change course can make choices. They have agency. They have purpose. They have destination. The question now isn't whether 3I Atlas can maneuver. We know it can. The question is where it's going, what it wants, why it's here. Those answers might come soon, or they might remain unknown as the object completes its pass through our system and continues into deep space. But one thing is certain, we're watching now, we're measuring, we're analyzing, we're preparing, and we're doing it with the knowledge that this object isn't just a rock, it's something more. Something that can accelerate during perihelion, something that can control its trajectory, something that chose to show us that capability exactly when we were watching most closely. 3I Atlas accelerated. That changes everything. And what happens next could determine humanity's future in ways we're only beginning to comprehend.